In this episode, I want to derive two integrals which from a previous integral. In that previous demo, we saw that the integral of 1 over 1 plus x to the fourth dx was equal to 1 over 4 root 2 logarithm 1 plus x root 2 plus x squared over 1 minus x root 2 plus x squared plus 1 over 2 root 2 inverse tan x squared minus 1 over x root 2. So consider now a similar looking integral, but here the numerator is an x squared. As before, we'll let x equal e to the u, so that dx equals e to the u du, and going through the same procedure as we did in the previous case, we will get 1/2 cosh u plus sinh u over cosh 2u du, which differs from that previous case in one respect only. There, it was on the numerator was a cosh u minus sinh u, and here we have cosh u plus sinh u. So the logarithm part of the integral will now be the negative of the previous logarithm part, and we will now get then integral x squared dx over 1 plus x to the fourth equals 1 over 4 root 2 log e 1 minus x root 2 over x squared over 1 plus x root 2 plus x squared, and the inverse tan part remains the same. So in the logarithm, what I've just done to make one the negative of the other is simply to invert the fraction which forms the argument of the logarithm. So that should be fairly easy to understand. Now I'm going to turn to an integral which doesn't look anything like what we started with, but it soon will do. And that integral is the square root of tan theta with respect to theta. So I'm going to let x squared equals tan theta, so that 2x dx is 1 plus x to the fourth d theta, and the integral is transformed to 2 integral x squared over 1 plus x to the fourth dx, which is just double the integral which we've just done in the few lines above. And so all we've got to do is double that, and we'll get 1 over 2 root 2 log to base e x squared minus x root 2 plus 1 over x squared plus x root 2 plus 1 over root 2 tan inverse x squared minus 1 over x root 2. And reverting to our original variable theta, recalling that tan theta is equal to x squared, we'll simply now get the integral of tan theta d theta is 1 over 2 root 2 log tan theta minus square root of 2 tan theta, and then plus 1, all divided by tan theta plus the square root of 2 tan theta plus a 1, and then 1 over 2 root 2 inverse tan theta minus 1 over square root 2 tan theta plus a constant c. And that does it. Thank you for listening.